So, we have been talking about various kinds of assignment statements in Verilog. So, recall we talked about the continuous assignment statement using assign, then we talked about the procedural assignment statement. So, looked at several examples where inside an always block or inside an initial block we can use various kinds of assignments to variables. These are called procedural kind of assignments. Now, broadly speaking, these procedural kind of assignments come in two different flavors. So, in this lecture we shall be starting our discussion to clearly distinguish and try to find out when and under what conditions should we use which of these two options or alternatives. So, the topic of our lecture today is blocking and non-blocking assignments. These are the two types that I was talking about. Fine. So, these assignment statements fall under the broad category of procedural assignments. So, what do you mean by procedural assignment? Procedural assignment is an assignment, an expression which assigns some value to a variable which lies or figures inside a procedural block. In Verilog, a procedural block can be either initial or always. Okay. So, these kind of procedural assignment statements can be used to update variables only of these types: reg, integer, real, or if you have a time variable which keeps track of time. You see, you cannot have a net type variable on the left hand side of a procedural assignment. This is the restriction. So, if you are using some variable to assign a value inside a procedural block, they have to be one of these data types. Now, you see there is also a very clear difference from the continuous assignment type. See, in continuous assignment which we had seen earlier using assign, let us say we write assign a equal to b plus c. Here, whenever the value of b plus c changes, the value of a will be immediately changing. It will be directly driving this net type variable on the left, and this net type variable on the left of this assign statement do not have any facility or capability of storing this value. That is why we call this as continuously driven. As b and c changes, a will be continuously changing, right. But in contrast, for a procedural assignment, there is an important difference to be remembered. The value that we assign to a variable, this remains unchanged until you assign some other value to that same variable again. Okay. So, there is some notion of storage or memory associated with the variables that you use here. So, once you assign some value to a variable, the value will remain unchanged until you again assign it to some other value. So, this is the difference from assign which I just now talked about. So, broadly speaking, this assignment statements inside procedural blocks can be blocking or non-blocking, and they are denoted by the assignment operator. Blocking is denoted by equal to, non-blocking is denoted by the arrow symbol less than equal to, this symbol. This means arrow. Okay. Fine. So, the rules for a procedural assignment statements are as follows. So, I already talked about that the variable on the left hand side should be one of reg, integer, real or time. This is of course a constraint. Not only this, on the left hand side we can also have a bit select of one of the variables of this type, like we can write sum 15 equal to something, right. This is one particular bit of a data of this type, or you can also select a part by specifying the index values like IR bit numbers 26 to 31 equal to something. This also you can mention, or you can concatenate one or more of this by enclosing them with the within the curly braces as I mentioned earlier. So, you can also use the concatenation operation, like for example, you can write concatenation, let us say a variable A5 comma a variable B, you can have a section defined or an entire variable C. So you can define a concatenation like this equal to, you can have any expression like x plus y. So, this kind of expressions are allowed provided A, B, C, these variables are one of these 4 types: reg, integer, real or time. But the right hand side of the expression can be anything, you can have any combination of net type variable and also register type variables, and these assignments as I had mentioned can appear only within an initial block or within an always block. So, just outside these blocks you cannot use these assignments, right. Okay. So, let us start with blocking assignment and let us try to understand what it really means. Now, the general syntax is, on the left hand side you have the variable name of the types, one of the types I mentioned, equal to, well, you can mention some kind of triggering event, like you can mention a delay or you can also mention an event like at some clock edge or something, that also you can mention. Variable name equal to some expression. So, for the time being let us ignore this. Variable name equal to some expression, this is the general syntax, and this equal to symbol is used to indicate blocking assignment. So, what is the meaning of blocking assignment? You see, so if inside a block there are several statements, the statements will be executed one by one in the order they are specified. Like suppose inside a procedural block begin end I have 4 statements. The statement will be executed one after the other in sequence. Suppose the first statement is A equal to B plus C. So, some value will be assigned to A. Second statement is let us say D equal to A plus 5. So, that value of A which was assigned, that value of A will be used, okay, in the next expression. So, in that way one by one sequentially the instructions will get executed. This is the interpretation of blocking assignment. That means, an instruction which is executing or an assignment statement which is executing, it blocks the execution of all the statements which follow. So, unless it is finished, the next instruction will not start. Okay. This is the meaning of blocking assignment. So, the target of an assignment statement will get updated before the next statement is executed, right. But if you have several blocks, suppose I have 2 always blocks, then a blocking type statement in one of the blocks will not block any statements in the other block. It only apply to the statements inside the same block. Okay. So, this point is mentioned, they do not block execution of statements in other procedural blocks. Now, this blocking assignment style can be used to model sequential circuits also, but it is recommended that we use this assignment style to model combination logic. We shall see a lot of examples later and try to find out why this is so. This is what I mentioned. So, using blocking assignment you can also generate sequential circuit elements. So, means we had seen some examples earlier, you recall those examples where you had a multi-way branching using case, where if all the values of the case variable were not specified. Suppose I am doing a case on a variable A which can take on the values 0, 1, 2 and 3, but I specify what will happen if the values are 0, 1 and 3, but for 2 I am not specifying. So, if the value is 2, what will happen? So, all the variables which appear on the left hand side, they should not change, which means they should remember or memorize their value. So, this synthesis tool what it will do? It will be generating a latch, a storage element for such variables. But if in the case statement you mention all the conditions without any ambiguity, then it will generate a pure combinational circuit. Okay, so, earlier we took some examples to explain these things. Okay, fine. So, an example of blocking assignment is shown here. This is not the complete Verilog module, just a segment of the module. Let us say A, B, C are 3 variables of type integer. So, inside a initial block I have this begin end. So, see the statements A 10, B 20, C 15. These are the 3 statements, one by one they will get executed. So, initially this A, B, C will be getting the values 10, then B 20, then C 15. Next statement is A equal to B plus C. So, B and C will be added, the value will go to A. So, it will be 35. So, the new value of A will become 35. The next statement is B equal to A plus 5. This new value of A will be used and 5 will be added to it. So, B will become 40. And the last statement is C equal to A minus B. So, the latest value of A and the latest value of B, they are subtracted and the result will be minus 5. So, this is the interpretation of the blocking assignment. Statements execute in the order they appear, just like what you see in a high level programming language like C or Java. Okay? Fine. There is one example here where various kinds of assignments are demonstrated, are shown. Here we are defining 3 variables x, y, z and 2 vectors of size 32 a, b. This is not a meaningful code, just an illustration. So, you say at the beginning we give some assignments, say x equal to 0, y equal to 0, z equal to 1. These are all single bit variables and sum equal to 1, sum is an integer. Because we have not mentioned any time delay, these assignments all will take place at time t equal to 0. Similar is the case for these 2 assignments, A 31 bit all 0 and B 31 bit hexadecimal. We initialize it with the hexadecimal number A B, A B, A B, A B. Okay. These all they happen at time t equal to 0. Now, let us say I write at time delay 5 hash 5 A 5 equal to 1. So, the 5th bit of A will be changed to 1 at time 5. Then I give another delay 10. So, I define a segment of B, these 3 bits 29, 30 and 31, they will be assigned a value which will be the concatenation of x, y and z. And this will happen after delay of 15, which means at time 15. And lastly, sum we are incrementing by 5. So, again because there is no delay here, this will also happen at time 15. Okay. This is just an example showing how the times are kept track of in blocking assignments. Now, here we take an example of a blocking assignment and we shall show the results through simulation, because there are a few things to understand here. This is the example that we take, 4 variables defined A, B, C, D. This is a always block, always at the rate star means any variable changes, and inside this block we are saying repeat this block 4 times. So, I am saying this begin end block has to be executed 4 times and each of them will be having a delay of 5. And you see we have written a test bench which monitors the values, the time, then A, B, C and D. These values will be printed whenever some changes of these variables take place. So, we start by initializing A to 30, B 20, C 15 and D 5 and we continue the simulation till time 100. So, at 100 we call finish. So, let us see when you simulate this code with this test bench, what is the output. Okay. So, I am showing here this code side by side so that you can understand what is happening. You see in the test bench we initialized A 30, B 20, C 15, D 5. So, I am showing the initial values here and this is the simulation output which you got, and on color I have shown the values which are changing. Okay. So, initially at time t equal to 0, A 30, B 20, C 15, D 5 was printed. Then at time 5 this A equal to B plus C happened. So, B and C was added and A became 35, others did not change. Then again after time 5, D equal to A minus 3. So, A was 32, D became 32, 35 minus 3, 32. Then again 5, B equal to D plus 10, D plus 10, B becomes 42. Then lastly C equal to C plus 1, C was 15, it became 16. Now, this will repeat 4 times. So, again A equal to B plus C, B is 42, C is 16. So, A becomes 58, D equal to A minus 3, D becomes 55, B equal to D plus 10, it becomes 65, and C equal to C plus 1, 17. So, this thing repeats 4 times, third time and a fourth time. So, at the end you get results like this. Okay. So, just by simulating this code you get results like this, where the variables change like this. So, the point to note there is that every time this loop is executed, you execute them statement by statement. One statement is finished, then only the next statement starts. Fine. Now, let us look at the second type of assignment statement, namely the non-blocking assignment statement. Now, non-blocking assignment is different from blocking in the way they work, and they are more suitable to be used for specifying sequential circuit behavior, as we will see through many examples later. So, first the general syntax. Syntax is very similar, variable name and expression, but instead of equal to we use this arrow assignment, less than, equal to, this symbol. This operator specifies non-blocking assignment. Now, as the name implies, a non-blocking assignment statement does not block the execution of the statements which follow inside that block. The statements inside the block, they can execute concurrently. This is a concept here. Okay? It is not that after a statement finishes only then the next one will start, not that. It is not blocking the other statements. So, all the statements can execute together. Okay? So, the idea is this. So, if you have a non-blocking assignment, then the assignment to the target which takes place, that will happen at the end of the simulation cycle of that block, that means at the end of the block. So, if you see here, the assignment to the target will get scheduled for the end of the simulation cycle, means the one run of the loop at the end of the block. So, here we will explain with an example. So, because it is non-blocking, statements after the instruction currently we are looking at executing will not be blocked. They will all be executing together, which will allow something called concurrent procedural assignment, which is very suitable for modeling sequential logic. We shall see this thing. So, let us take an example. As I had mentioned, this is the recommended style for modeling sequential logic, where a number of reg type variables can be assigned synchronously under the control of a common clock. But here it is just a simple example I am taking. Here this is just a test bench I am writing, there is no clock. There are 3 variables A, B and C. So, in one initial block I am initializing them to 10, 20 and 15, and in the second initialized block I am using non-blocking statement with some delay identifier. So, the idea is that when there are non-blocking statement inside a procedural block, then all these 3 statements are executing concurrently, meaning the right hand side expressions, they will be evaluating together using the current values of A, B and C, and after the delay which is specified, they will all be concurrently assigned to the variables on the left. Okay. So, in this example, let us say A is 10, B is 20, C is 15. So, on the right hand side, B plus C, A plus 5 and A minus B will be evaluated first. What is B plus C? B plus C is 35. What is A plus 5? It is 15. What is A minus B? It is minus 10. So, they will be assigned all together at time 5. So, A will become 35, B will become 15, C will become minus 10. So, you see the final value that ABC gets here is quite different from what it got when you used a blocking assignment statement. So, when you use blocking and when you use non-blocking, the results are different. So, you should be careful when you are using it to model some behavior of a system or a circuit. Okay. So, as I said that all the right hand side expressions are evaluated together based on the previous values of ABC, not these latest values, and they are assigned all together concurrently at time 5, right. So, this is a more common way where we use this kind of non-blocking assignment with a clock. This statement means whenever there is a positive edge of a clock, you compute these expressions and assign them to these variables concurrently. So, all assignments take place synchronously at the rising edge of a clock. You see, this is quite natural from hardware point of view, because in any hardware register there is some kind of a clock signal. So, whenever there is a clock and there is a load, the input value gets loaded. So, here also something similar can take place. The right hand side can be evaluated and the values can be made available to the input of the registers. As soon as the clock comes, all those input values will get loaded in the registers. That will happen exactly when the clock comes. Okay. So, that feature can be modeled using this POS clock facility. And as I said, this is the recommended style for modeling synchronous sequential circuits where there is a clock and you are wanting assignments to take place in synchronism with the clock, right. This is the recommended style. Now, let us take on one example. Suppose we want to swap the value of two variables A and B. Swapping means if A is 10 and B is 20, so we want to make A 20 and B 10, interchange their values. Let us look at various styles of doing it and let us see that whether swapping actually takes place or not. Okay. This is the first example I am taking using non-blocking assignment with two always blocks. Both are activated at the positive of clock, there is no delay. So, at time t equal to 0, just immediately after the clock edge comes, these will be executed. So, you see, because these are concurrent blocks A equal to B and B equal to A, they are actually executing concurrently. But you see, when you are simulating this, depending on the simulator will be either doing this assignment first and then this, or the reverse. So, if A equal to B is done first, then B will be going to A and that value of B will again be copied to B. So, both A and B will be getting the value of B that was there. But if this statement executes first, then the value of A is get copied to B and that same value remains in A. So, both the registers will finally get the same value, but it can be either A or B, you do not know. It depends on the simulator, how the simulator actually schedules these two operations execution, and this is called a race condition. Depending on the relative order of execution, the final result can be either A or it can be B. Okay. Let us look another example. Same one, instead of blocking I am using non-blocking assignments. See, here there is no problem, because these assignments will take place only when positive edge of clock comes and they will take place together. So, the right hand side will be evaluated. So, right hand side B, right hand side A, that values will be taken and they will be assigned to A and B at the positive of the clock. So, there is no question of indeterminism like in blocking assignment that was happening here, okay? Because here there is nothing that says that whenever the clock comes only then it will be assigned. Blocking says it will be done one by one. It can be either this or this or this, first this or this, depending on the order of execution. So, if you use non-blocking statement, then the variables will be correctly swapped, because the right hand side variables are read first. Let us say A equal to 10, B equal to 20, they will be read first, and whenever the positive clock edge comes, 20 will be assigned to A and 10 will be assigned to B. Okay. So, swapping will actually take place. Let us take another example. Suppose we are using blocking statement to try to swap. Suppose I write A equal to B, B equal to A, what will happen? Inside a same block, just try to see what will happen here. First, this statement will be executing, B will be copied to A and then this will be executing, A will be copied to B. So, both A and B will be finally getting the value of B. Okay. Because this is the first statement to execute, the value of B, if it is 20, 20 will be copied to A. So, A will also become 20. So, 20 will also be copied to B again. So, both A and B will be 20, the previous value of B. Okay. So, using blocking statement, if you want to really do a swap, you can do it like this by using two additional temporary variables T A and T B. You first this assign A to the temporary variable T A, then B to T B, then T B to A and T A to B. In this way, swapping will correctly take place, but of course, you see you have to use two additional variables. So, this example shows you that using non-blocking assignment for certain application can be very convenient, as this swapping example is one of them, it shows you. Okay? Fine. So, let us similarly simulate one example using non-blocking assignment, same example that is short for blocking, but here I use non-blocking assignment. So, my test bench is also similar, but since here we use a clock, so I am applying a clock here. So, what you are doing? We are using the monitor to just mention what are the variables to print, then we initialize the variables, clock also is initialized to 0 and in a for while loop we are generating the clock signals. Forever is a loop which goes on indefinitely. We say that after a delay of 5 you do clock equal to not clock. So, the clock signal will be generating like this. Clock was initially 0. So, after a delay of 5 it becomes 1, after a delay of 5 it becomes 0, after a delay of 5 it again becomes 1 like this. So, a clock will be generated with a time period of 10, right. So, this forever statement generates this clock and we continue simulation till 100. There is another initial block where you say at 100 you finish. Let us see the simulation output for this example. So, I have shown this side by side for convenience. Initially A 30, B 20, C 15, D 5, that is the first value which is printed at time t equal to 0. Then just this is the statement, positive edge of the clock is coming after time 5, okay. Clock was 0. So, after time 5 the first clock edge comes, right. So, at time 5 the first change will take place, the positive edge comes at time 5. So, B plus C will be assigned to A minus 3 will be assigned to D, D plus 10 to B and C plus 10 to C. What is B plus C? B plus C is 35, A minus 3 is 27, D plus 10 is 15, C plus 1 is 16. So, all the values are assigned together, you see 35, 15, 16, 27. Now, next clock positive edge will be coming after the time period 10. So, next one change will happen at 15. So, again you do this with these new values, B plus C 15 plus 16 31, A minus 3 32, D plus 10 37, C plus 1 17. You see all these values are assigned parallelly 31, 37, 17, 32 and these repeats up to the time 100. So, 95 is the clock edge that you get before 100, last change will take place at 95. So, this is how the simulation result shows. So, there are a few rules which you should remember when you are using this kind of blocking and non-blocking statements in a procedural block, and these are summarized here. You see, the first thing I told you is that blocking statement is the recommended style for combinational circuits for specifying combination logic, and non-blocking statement is a recommended style for specifying synchronous sequential circuit. So, the first thing to remember is that you should not mix blocking and non-blocking assignments together in the same block. Well, it is not that it is not allowed. I shall show you some examples later where you will show that what will happen if you mix them, but it can make the things complicated for you. Simulator or the synthesizer may allow, but this is certainly not a good design practice. You should avoid this. You use either blocking or non-blocking inside a particular procedural block. The second thing to remember is that these delays that you show or you specify, these are only for simulation. So, when you are doing synthesis, so all these delays will be ignored. So, the design which is working perfectly in simulation may not work exactly as you just want them to work in the final synthesized hardware. So, that is why you should keep these things in mind. Okay. Secondly, say a particular variable you cannot have it as the target of a blocking as well as non-blocking assignment together in two blocks in the same module. If you do it, the simulator or the synthesizer will give you a warning on an error message. Okay. So, with this we come to the end of this lecture, where we had looked at mainly the differences between the blocking and the non-blocking assignment styles. So, we shall be continuing our discussion on these two styles over the next few lectures, because this is very important in modeling, and unless you understand clearly the differences between the two and what will happen if various types of combinations you use, it will be difficult for you to understand the interpretation or the semantics of different structures. So, we shall be continuing with these in the next lecture as well. Thank you.